Hi everyone, I'm Dedun Samarsekara. Today I'm going to talk about Transmission Control Protocol, which is called as TCP. Actually, TCP is an important network protocol which is used in transmission of data. It is related to layer 3, which is transport layer. Protocol TCP is a protocol. Protocol is a set of rules and procedures that control how the transmission of data is carried out, so that everyone in the world, regardless of the location, software, or the hardware they use, work in the same way. TCP works together with IP, which is called as Internet Protocol. Normally we call TCP IP, both together. You can see this term in the network settings of your computer or your smartphone. Uh, the IP part deals with the addressing and forwarding the data packets from source to destination, um, while TCP manages the reliability of the transmission. What is the role of TCP? Actually, TCP controls the transfer of data in a way which is reliable. In Internet, data is transmitted in packets. Each packet sent independently on the network and are reassembled once they reach the destination. That's how it's give back the original data. TCP is responsible for ensuring reliability during transmission. A reliable data transmission should ensure a set of requirements. The first one is all the packets reach the destination, that is, no packet is lost, actually. There is no such delay that would affect data quality, and all data packets are reassembled in order. Actually, TCP ensure all those factors. And now we can see how TCP works. Actually, TCP use the three-way handshake. Um, TCP label its packets and also make sure they have timeout to reach the destination, which is a duration of several hundreds of milliseconds. And when each packet receives the sending device, uh, that device is notified through the packet called acknowledgement. If after the timeout no acknowledgement is received, then the source send another copy of probably missing or delayed packet. This way, all packets are always assembled in order. This is called three-way handshake. And if we consider the TCP addressing, since IP has good addressing mechanism, and TCP and IP work together, TCP doesn't need one. It's only use numbers provided by the device it is working on to identify whether it is receiving and sending packets for which service. These numbers are called as ports. As an example, web browser use TCP port 80 for HTTP traffic, and TCP port 24 is used for sending emails, which is SMTP protocol. In here, this example, this 80 is the port. Let's move to Wireshark. Okay, and this is Wireshark, and I'm clicking on my Wi-Fi. And we'll search for some sites. And here I'm filter from TCP, and here I have some good set of traffic, good set of packets, and we'll see the transmission control protocol of the first packet, which is a sync, which is sent from my machine to this is IP of the Facebook. And inside this one, there's a source port uh, which send the packet, and the destination port who receive the packet. And in here, there's an important information. This is the source port and the destination port, and other than that, there's a sequence number. As I said earlier, those packets are sending according to the sequence, and that number and the next number will be displayed here. And also there's a flag. Inside the flag, since this is a sync one, uh, it has marked as 1 in sync. And if we check this sync and act, it should display the acknowledgement 1 and sync 1. And if it's an acknowledgement, it should be acknowledgement 1. And this one, this window size also a very important information. This is this explain the bits we can send without receiving the acknowledgement of the previous one. Actually, within the one frame, how many bits we can send. It will be increased gradually, and after it's come to the level, it will continuously keep that bits window size to that communication. It can show by this graph under the TCP stream graph. There's a graph. You can see gradually it increased the packets, and within a time try to increase the number of packets, number of bits sending at once. And another important one is the checksum. Actually, this checksum says whether this packet stream is okay. And other than that, there's a timestamps. This actually says from the beginning of the stream up to this packet, how many seconds passed, and this one is from the previous frame to this frame, how much time passed. Other than that, there is some more graphs in Shark. This is a round trip time. This displays from the for one round how the time taken. to complete one round. That means source to destination acknowledgement and sync and acknowledgement back to the source, and again so from source to destination acknowledgement. That's all about my presentation, and thank you very much for watching this presentation.